All right. So the only two technical sections that I'm going to cover in this training are one is virtualization and the other is networking. Like this is something, the ones that are starting from nowhere are not used to seeing something in-house. Like the stuff that we have seen so far is all out there. But like this part, you won't come across uh, anywhere in your life unless you're working in an IT company. All right, so this is the kind of machine that you're used to seeing at home. It has one CPU, it has one network card, and it has some memory. And the same thing was happening in the companies, but the applications they're running required more horsepower. So they added more CPU, more RAM, more network cards to the same machine. Requirements got bigger, and these machines got even bigger. And then there is only so many CPUs and RAM you can add to one of the servers. So they started stacking up these servers, the big servers like this in arrays. And this is what it used to look like back in the day. So uh, I don't know if you can make out, but like this is a rack filled with large machines like this. And then this little monitor and keyboard was the only thing that we used to work with, and we would physically connect to individual machines to do maintenance. So this still looks not too bad, but now the back of this machine, and this was a management nightmare for people like me who had to be working and reconfiguring these machines. And not one, the first thing first, it has been offloaded to Amazon, and now that's called cloud computing. That's a different story. But this was a very inefficient model for working. So the next phase that uh, was of the computing, well, this is where we are right now. Big machine, a single OS. Uh, and the problem with this architecture was if you're running three different processes on this machine, one process could take a whole lot of memory or a whole lot of CPU and all the everything else running on that machine. Even though this is such a giant machine, the other processes won't get anything. So the first kind of solution that was implemented was hardware partitioning, where we will actually divide the machine physically into multiple pieces. And now the top section is one CPU machine, so is the second one, and the bottom one stays a two CPU machine so it can handle bigger workloads. So now, if the situation changes, let's say the bigger workload on the bottom machine has gone away, and there are two smaller applications need to be put on this machine. So now you're back to breaking it into two machines physically. Same way, if you need a bigger machine for the top two, once again, you have to physically take the partition out, and not very efficient. And that's where the concept of virtualization came in, where a operating system sits on top of this entire machine, and the in today's world it's called hypervisor. And on top of this hypervisor creates smaller logical machines as you need, merges them, breaks them apart, but without having to actually go to the hardware. And that's basically the concept of virtualization. I am not sure if it was helpful, but it's a very deep topic, but hopefully it gives you a rough idea of what it is. So this VM is what we work with in a cloud environment. But now one more thing that I need to add is hard disks. So same way you can either add, this would get divided the exact same way the machine was getting divided. But now in today's world, this is just one big machine with disks attached to it on the inside. And these are the internal disks that the machine uses. They are inside the machine. And the second type of disks that we have are called Nass discs. And now this is a giant array sitting somewhere on the network, which has a lot of hard disk and lot of capacity. I mean, like it could be in petabytes. So the main thing to understand here, the disks inside the machine are limited in size. You cannot put like a petabyte of data. It's going to take way too many disks to put inside this virtual machine, well, physical machine. And so there is a limit on these, but they're extremely fast because they're so close to the CPU and the RAM, basically the hardware of the actual machine. Now, this disk on the NAS, however, can be of any size, but there is going to be some lag compared to the internal. So internal disks are fast, external disks are a bit slower than that, but the internal disks, limited size, external disks, unlimited size. Uh, that's pretty much the takeaway from this slide is. Now let's look at this VM and how we look at it. Like this is the actual hardware picture in the back, but we don't really need to concern ourselves with this, but just knowing this is how it is set up helps to relate with things. Now the thing that you would be looking at is a EC2 virtual machine like this. Now, this is a logical machine. This is not a physical structure. The structure that you work with in the cloud, the machine that you work with in the cloud, are not physical machines. Most of the cases they can be, but this is what you're looking at. And now this could be anywhere. So this machine having two CPUs in the back, the physical machine that this virtual machine sits on could have 100 CPUs, but that's like not really our concern. The virtual machine that we got has two CPUs, some RAM, two network cards, three internal disks, and two external disks. And the thing to understand here is the CPUs are available to this machine. They could be part of a giant cluster, but it doesn't matter to us from a performance perspective. But it does matter from a licensing perspective, and that's a little advanced topic, but just something to know. The network cards are attached to this virtual machine. And when this is something part of networking when we'll talk about, actually, let's just talk in that section. Once again, three internal disks going to be way faster and two external disks, which could be much larger, but they will be a little slower. Uh, and that's all I wanted to cover in this chapter. In the next section, let's talk about networking. Sorry, I'm not going into too many details, but I could literally talk on this for 2 days straight, and there'll be still something left out. But just trying to give you a high-level view of what goes on into the compute machines in the cloud.